Welcome to Module 8, Lesson 4, where we open the terminal and dig into one of the most practical topics in networking. Today, we're talking about quality of service, or QoS, the mechanism that decides which traffic gets the VIP treatment when your network starts to feel the squeeze. Think of it this way. When a voice call and a bulk email are competing for the same pipe, QoS is what makes sure the voice wins. So, why does QoS even exist? It comes down to a simple truth. Every link has a ceiling, and when traffic exceeds that ceiling, something has to give. There are really four characteristics that shape how traffic behaves on a network. Bandwidth, which is how much data you can push per second. Delay, the time it takes a packet to cross the network. Jitter, the variation in that delay. And loss, packets that get dropped when things get congested. And here's the key insight. Voice and video are real-time, so they feel every bit of delay, jitter, and loss. A file download, it just waits. That asymmetry is exactly what QoS is built to manage. That asymmetry leads us to classify traffic into categories, because not every flow deserves the same treatment. Voice sits at the top. It barely sips bandwidth, but it demands almost zero delay and jitter to stay intelligible. Video needs low delay too, but in big, bursty chunks. Business apps want to feel snappy and reliable, while bulk traffic, your email, backups, web downloads, can happily wait its turn. QoS is what makes sure voice goes first and bulk goes last. So how does QoS actually pull this off? It starts with classification and marking, identifying traffic at the edge of the network and tagging it with values like DSCP or TOS, so every device downstream knows what it's looking at. From there, queuing puts each class into its own line and decides who gets served first. Policing drops traffic that exceeds a limit. Shaping smooths it out by buffering, and congestion avoidance, typically WRED, drops a few packets early to keep queues from overflowing entirely. The pattern is simple. Mark once at the edge, then queue and police or shape everywhere else. Let's zoom in on those markings, because they're the vocabulary every QoS-aware device speaks. DSCP lives in the IP header at layer 3 and is what you'll use almost everywhere. COS is its layer 2 cousin, only relevant on trunk links between switches. The values fall into a few families. EF, expedited forwarding, is reserved for voice and carries DSCP 46. AF covers video and important business apps. CS exists for backward compatibility with older IP precedents. And DF, or best effort, is plain DSCP 0, the unmarked masses. If you remember just one number for the exam, make it EF equals 46. And that wraps up our look at QoS classification and marking. You now know why voice gets the VIP treatment, how traffic is identified, and the magic number 46. Next up in Lesson 5, we shift gears into first hop redundancy protocols, focusing on FHRP, and then we'll recap the entire module. If this lesson helped, hit subscribe and turn on notifications so you don't miss it. The full CCNA course is free on YouTube and over at Dargslan.com. See you in the next one.